In a video I released maybe 2 or 3 weeks ago, I explain a mechanism by which you can easily detect when on a patch system somebody attempts to exploit the curveball vulnerability. This pernicious attacks is on the elliptic curve cryptography, and in that video I show how we get a log that allows us to fire an offense, and all that is, you can see the details on that video later. But some people say, well, but that is good, but how can I detect this regardless of whether the system is patched? And for that we need to look into the payload that goes across the network. And the reason why we can detect that, and I'm going to try to make this simple, but you can Google this and see the details. Mutas explained this to me, and he's the one who provided me this use case. And the actual attack gets reduced to the fact that the public key Q should always be a factor of two numbers. One is a large number called the generator, or G, and another one is this factor D that probably is a very large prime number or whatever. And the attack is actually happens when D is made to be 1. So in other words, the public key and the generator are exactly the same. So fast forwarding on what we are going to be seeing at the end of this video, what we get is you probably see me many times showing the capabilities of QNI extracting fields from the payload. But what you probably have never seen is QNI extracting this field, the public key and the actual generator and all those details. And as you can see, the public key is exactly the same as the actual generator, because this is an example of that particular attack. So if we are able to extract these parameters and send those from QNI to QRadar, as it does so well as IPFix net flows, then in QRadar we can have a rule that tests for the equality of those two parameters, and QRadar can easily fire an offense. That's the objective that we want to accomplish to do that. Now, where are the things that you need to make this happen? Well, as you probably know by now, there's a box link, a public box link that I keep where I put all this particular material, and you get to it by clicking in the video description of all my videos. There's this link. When you click in it, you get sent to that box link, and I added today this material in here. Notice that it's clearly labeled as unsupported. If this doesn't work, don't call support, IBM support, for it, because they will not acknowledge any of this work. But in here we will see all the components that you need. Let me go back to the whiteboard and explain the steps to get there. So the first step, and again overemphasizing this is unsupported, is to say, hey, QNI, I want you to extract those fields that you don't normally do, that you show me there with the public key, the generator, and all those details. And you do that by running this script in your QRadar system. Again, better try this in a development environment. Don't do it in a production system. It works well, but if you do this, for example, as all the certificates that go across, there's more data that gets extracted from every cert. So that may have a small impact on your storage volume, or, but I don't think it is significant, but keep that in mind. This is not officially blessed by IBM. So once you have done that, you need to create a rule in QRadar that tests for the equality of those parameters, and that is done with an AQL statement. That AQL statement looks a little bit intimidating, but it's in here. We'll see all that playing later. That is the piece that you will put in the AQL. Right? That's what tests those two parameters for equality. How you test this out? Well, we want to make it easier for you by providing in that box link two things. One is the actual, actually let me go back. One is the actual pickup that contains that attack that we see here. And you run that by executing this mutas shell script, which actually invoked this other script. And this basically what it does is it simulates that the actual traffic and that pickup is sent to the QNI box for it to replay it and generate the same action as if this would be coming through the network. So let me actually go to the QRadar system and show you that. So this is the actual offense that fired. Let me display the rule that you can easily create yourself. That's the title that we gave it. You may want to put it here unsupported at the beginning. And then you see that AQL condition that I showed you before right in here. I mean, this fires an offense, as we can see here, and we put it the category of exploit and the low-level category miscellaneous exploit. So this is a standard QRadar stuff. Now let's actually close this offense and start with a clean slate. So I moved those files into my QRadar system. I already cleaned all the offenses, as you can see, and I'm going to run that script again. And as you can see, this is going to be sending that pickup to the QNI box for the processing. And I'm going to pause the video. This takes maybe a minute or two for all these things to fire up and get the offense that we were looking for. Here we have two offenses. Let's go into, we'll get back to the other one in a minute. That's also related to this attack. So we open this offense and we look at the traffic. This traffic takes about a minute. Those buckets are processed every minute. And then we can actually see, you see, it hasn't come yet. So let me wait until the minute passes to go back here, and we should see that flow. So let's click again. We should have it by now, and here it is. And this is precisely the same that I showed you at the beginning, but now that we replayed it, right? And we're going to see the other offenses related to this particular aspect, non-standard port. It detected something funny with the strength of the encryption, and it's a self-signed certificate and all that good stuff. But here are the details that we saw before. And the other offense is precisely the detection in my QNI system of that suspect content. And we have the three flows in here. And it's precisely by the detection of that strange fields in there. Notice that this is a certificate that is supposed to be, is a forged certificate that appears to be by google.com. And actually the signer is bing.com. So this is the bad guy can make all this up when they exploit this particular vulnerability. But I hope that this show you a way of detecting this pernicious curve of attack happening anywhere within your network, regardless of whether your machines are patched or not.